settings for allowing you to enable disable the mute unmute button. Can one of you please try that and let me know if it is working? If it doesn't work today, then I'll talk to some other faculty and see if it if in the WebEx training there is an option, because the way I have set up this lecture series is through WebEx training. I'm not sure how the other faculties are using WebEx. You could be using it like just using your personal room, right? So I'm not sure if people are using it as a personal room, but I'm using it as a WebEx training. So that's why I'm not sure if it is the same way I've set it up. But anyway, if there's a problem today, I'll talk to other faculty members and see, how to work with it. Okay, it's not working. We can switch to Google Meet. The only thing is, did you know if other faculty members with this class size are using Google Meet? Because I used to use Google Meet, but earlier it had a limit of 250 participants. Recently, I think we have heard that when I, as a faculty, set up the Google Meet, I think it would allow up to 500 students. But I'm not used Google Meet with this large class size. So therefore, okay. So in training session, you can unmute too. Okay. So thanks, Kushi. I will. Can you tell me the faculty name whose training session you're using in the if you tell me who's which subject or which course or which instructor. Okay, Sunita. Okay. So I'll talk to Professor Sunita and take her help on this one. Okay, Sweta Garg also. Okay, ठीक. I'll talk to one of them and I'll try to figure it out. Hopefully before the next lecture, which is on Thursday. So today, please just use the Q&A part, which you had been asking questions earlier too, right? So I'll answer your questions through the Q&A panel right now. Hopefully by the next lecture, I'll figure out what to do. So I tried to play around with it myself today, but I guess it's not working. Okay, all right. Thanks for your input, guys. Hopefully we'll figure this out next in the next lecture. Okay, so before we begin, do you guys have any questions? So let me tell you that the lab is scheduled for tomorrow 2 to 5, and in the Moodle. So let me share my screen first, and let me also start the recording. Okay. So in the Moodle, you will see that there's a Excel spreadsheet which I've uploaded in the course details, which has a TA student group assignments. Okay. So when you look at this Excel, you will know who is going to be the TA you are going to work with. So I basically assigned the TAs to the student group so that the same set of students will work with the same TA, and hopefully that way you create the comfortable relationship with your TA, and they'll be able to help you better, right? So that's the way we will do it. In the lab sessions, what we plan to do is that 3 TAs groups will be in a single Google Meet, right? So single Google Meet, which will have 3 TA students, and I think I've assigned about 28, 29 students per TA. So there will be about 90 students in each of the Google Meet, right? But you basically, the reason we have done it is so that in case if one of the TA is not available on some lab sessions, then at least there are 2 other TAs who can also sort of fill in for them, right? And also in case if you ask question, let's say one TA may not know the answer to that, but maybe then other TA may know the answer, and they will also be able to fill you in for those questions, right? So therefore we try to combine 3 groups, 3 TA groups in a single Google Meet, but also not having the whole class in a single Google Meet, so that it doesn't become a chaotic situation, right? Because if many students ask questions at the same time, it will become problem to manage it. Okay, so again, because it's an online mode, it's somewhat difficult to also manage the lab sessions for us, but we'll do our best to make sure that you get the help that you need. Okay, so you should have received the Google Meet invite or link from your TA groups. Okay, if you have not, look at this Excel and you can send an email to your TA. Okay. All right. So let me proceed. So we basically were looking at the shell scripting, right? And in particular, we were looking at the variables, right, in shell scripting. And we looked at the local variables and the environment variables. And we also looked at how to create our own environment variables and how they are accessible. So now we are going to look at some more special variables and more of the shell scripting stuff. So one of the important special variables that you may sometimes need is the process ID of the current shell process that is running. So what does it mean? It means that if you recall, we use PS command to gather the information about which are the processes currently running for this particular shell window, right? And we see that there are 2 processes. One is the bash, and bash is nothing but the shell program. Remember, I showed you that if you look at ls-bin bash, this is the program file that we are actually running as the shell command, right? As the shell program. And so that is the process, right? So whenever this program or application runs on a computer, that is what we call process, right? So all the running applications are called processes. That is how the operating system defines them. Okay, and the operating system says that I have 2 processes running. One is the bash program, the other one is the PS program. And the bash program is having a process ID of 2072, and PS program is running with the process ID of 2474. So what is the current shell process ID, which is 2072? So if I want to get this information in my shell script, right? If I want to read this process ID in my shell script, how do I do it? So the way you would do it is, if you write $, right? You see that in the slide, it says $ and then $. So first $ is just to read any variable. So if you recall, in the previous lecture, we said that we can do echo and then $ and then path. Now, why we are doing that? Path is the environment variable name, right? $, $path is basically allowing us to access the value of path variable, read the value of path variable. And echo command allows me to display whatever I'm putting over here. So if I just say echo, I am studying IT215, right? It will just print that message. I am studying IT215. Okay, so echo is command which is nothing but displaying something which you provide as a parameter here. So $path is a parameter to the echo command, and path is the variable, environment variable, which is what we are displaying. Okay, so instead of displaying path variable, what we will do is, if we say echo dollar and then another dollar. So this dollar, actually the second dollar, indicates the process ID of the current shell in which we are running this command. Okay, so you will see that when I run this, I'm also getting the value of 2072, and that 2072 is the process ID here. So in short, if you want to access the process ID of the current shell in your shell script, you can actually use $. $$ is going to allow me to read that value inside my shell script. So that is one of the special variables that we have. Now, most of you, I believe you would have studied C programming language, or maybe some of the other programming languages too. Generally, programming language accepts the values from the terminal window, from the command line, right? Similarly, shell script also can accept the values from the command line or terminal window. Okay, I mean, the C programming language has two variables. One, we normally call it as argc, and argc normally says that it's an integer data type value which says how many arguments, how many values you are passing to the program through the command line, right? So that basically is this one, number of command line arguments. And in the shell script, if you want to read that value, you can use $. Now, if you want to read an individual values, individual arguments, right, you will be using $1, $2, $3, and so on. So if you have, let's say, 10 values that are entered in the command line, then you would use from $1 all the way up to $10. The first argument, $0 value will always point to the file name of the shell script which you are running. Okay, so $0 will give you the file name of the shell script which you are running. $1 all the way up to whatever number of parameters you have passed or argument you have passed will be coming as $1 through $n, and the count or the number of command line arguments will be retrieved as $pound. Okay, so that is an example that we will take a look through this small shell script. Okay, so here we just specify that we are going to be using. So this is my shebang, right? So through this first line, I'm specifying that I'm going to run this shell script in my bash using my bash shell. Okay, now I'm saying that my first parameter, first value $0 is my file name, the shell script file name. So I'm going to basically just echo that value. Okay, what is my first argument? What is my second argument? And how many arguments I have passed to the shell script? Okay, so this particular shell script is called test.sh. As you can see the file here, right? So I'll be running that file on a terminal window. How do you execute the shell files? So if you see the test.sh exists, okay, and how do I execute this file? I execute by saying current directory / test.sh. So I'm basically providing the path of the shell script. I'm providing the path of the shell script because this shell script is not in the path under the path variable, right? So path variable does not have this particular current path which from where I'm actually running the shell script. So I have to provide a complete path. And this is my complete path. So I'm saying current directory /test.sh. And that is what is going to run the shell script. Now, if I press enter here, you can see that it is not able to display any of the argument values because I have not provided it. Okay, it just has the file name, what I'm passing it to, right? And it says that the number of arguments is 0 because I didn't provide any number of arguments. But if I, let's say, provide some argument, let's say 1, 2, 3. Now it is saying that total number of arguments are 3, including my first argument, excluding my first argument because there are 3 arguments here, 1, 2, and 3. And then the first argument is 1 value, second argument is second value, and so on, right? I can provide any value. So it doesn't have to be 1, 2, 3, right? I can say A, B, C also, and that is also fine, right? So now it is saying that the first argument is A, second argument is B, and so on. Okay. Maybe I will provide only 1 value. Okay, then it displays the first value, and then it says that you have only provided 1 argument, and so on. Right. So this is the way you can actually pass the value to the shell script from the terminal window. Now, we know that whenever you write your C program, okay, there is an exit command, generally speaking, at the end we put, right? So for example, let me go to my C program and I'll show you what I mean. Okay, so you see that I've used here exit function. So what is this exit function do? Basically, I can provide some number here in the exit function, and this value will be returned back to the operating system when I run the executable file of the C program. Okay, so this is my C program. I'm including these 2 header files, and this is my main function, right? And as you can see, I have 2 arguments to the main function to accept the values from the command line. Okay, so argc is an integer type which has the count or the number of arguments, and then this is nothing but the array of strings. Okay, so array of strings is going to receive each value in each index as a string. So I'm checking if the number of values that I'm getting, right? If the number of values that I'm getting, or the argc. Now here you see there is a slight difference between the count in the shell script and the count in the C program. In the C program, it also counts the program name, which is my first argument. So again, here also the first argument, which is at index 0, will always be the executable file name. Okay, but that executable file name is included in the count here, in the argc count. Whereas in the shell script, the total number of parameters does not include the actual file. So that is the difference between the shell script and the C program. But once you know that, it is not a problem, right? So here we are checking that if the argc is less than 2, which means only the file name is provided without any arguments, then I am going to return the code of 1 to the operating system. If there is at least 1 argument provided, meaning that the argc value is equal to or greater than 2, then I am going to return 0 value back to the operating system. So now, how do I compile? How do I get the executable file of my C program here, right? So in the last lecture, I mentioned that we will be using a GCC compiler. Okay, so GCC is the compiler which I will be using, and I will say GCC and the program name. So retstat.c. Now, when I run this, it will compile my code. It will compile my code and create an executable file. What will be the file name of the executable code? It will be called a.out. So by default, all the program that you compile, all the C program that you compile, and without providing what is the output file name that you want to generate, all the executable file will be called a.out. But it could be a problem because you could have multiple C files that you want to compile and you want an executable for multiple C files. Now, you don't want all of them to be called a.out because all of them will be overwritten and only last one will be left, right? So you want to actually provide the executable file name similar to what you have as the source file name. So in my case, I want to actually say that GCC return status dot C minus O option. So minus O option of GCC lets me specify the output file, meaning that my executable file name will be what, right? That is what the output file for me is. So I'm going to say set.out. Okay, and now if you do ls minus ltr, you can see that this file is now created at this time. This is the old file that was created a minute ago, right? So that means that this is my executable file name now. Okay, and I can run this and I can provide the argument to it. So for example, to run this file, again, I have to specify the file name .out, and if I don't provide any argument and say enter, it says the value of argc is 1. Why? Because that 1 includes the file name itself. Because remember, I told you that zeroth index argument is still the original file name, the file name that you're running, the executable file name that you're running. And C program counts that in the argc value also. Okay, whereas in the shell script it doesn't. So here argc value is 1. But now if I provide, let's say, other values, let's say A, B, C. Now you see that arg value of, now you see that the value of argc is 4, right? Why 4? Because 1 is for A second. So this is 1, this is second, this is third, and this is fourth, right? So you have 3 arguments plus the file name. So there are 4 arguments in total. But you see that here I did not actually read the exit value. Exit value of 1 or 0 was not read, which is what I have provided here. So in order to read these values, which is returned back to the operating system from this program, what I have done is I have actually written a shell script. Okay, so we are actually going to be calling this C program, C executable file from the shell script and not directly from the terminal window. Okay, now in order to read the exit status, okay, you can basically use this $question mark parameter. So this is again a special type of variable which reads the exit status of the last command executed. Now, this last command could be a C program. Your last command could be any other command line, command line program also. So it doesn't always have to be C program only. The exit state, all the utilities, all the commands that are given to us by the operating system also returns some sort of an exit status. And generally speaking, 0 indicates success, meaning that the command was executed successfully. Okay, a non-zero value, whether it is positive or negative, it doesn't matter. Non-zero value generally indicates error. Okay, and depending on which command you have executed, you may get multiple values in the return in addition to 0, indicating different types of errors. Okay, so for example, if you are running a program and if you kill the program in between by pressing the Control-C command, right? So when you press a Control-C on your keyboard to kill your program, the program, generally speaking, will return code of 130 back to the operating system, indicating that the program was killed by the Control-C key combination. Okay, So that is how you would be able to read the exit status of the command. And so that is what I'm going to show you. So what we do is that first we, execute the C file using these two parameters. Now, when we pass the parameter, we know that the exit code will be 0 because the argc value will be greater than equal to 2, right? So I should get the value of 0 in the return value. And here you can see all I am doing is I am actually saving this value in this variable, in this shell variable. So this is my local variable. And in my local variable, I'm just reading this value and saving it. And then I'm just echoing this local variable value. That's all I'm doing here. Okay. So in this case, I'm expecting the value to be returned is 0. If I don't pass this parameter, I'm expecting the value to be returned as 1, right? And that is what I'm going to see in my output. So let me run that. So I'm going to say return status.sh because this is the shell file which we are running now, not the C program file. So you can see return status.sh is my shell file which I am running, right? And I'm going to run this, and as you can see what happened, right? So value of argc is 3. Why 3? Because there is a file name which is 1. There is a first parameter and second parameter. So total 3 values. Okay. And because there were 3 values, this condition was false, and therefore the exit code was returned as 0. And that is what is displayed here. This is my exit code of 0. Now, if I change the shell script and if I don't pass any arguments here, right? If I don't pass any arguments here, then the C program is supposed to be returning me exit code of 1. And that is what my shell script is supposed to display. So you see that the argc value is 1 and the exit code is 1. So in short, we can actually read the exit code from a C program or even from a previous command, right? How do we get the code from the previous command? Is like same thing. So instead of running a C program, I can actually run here, let's say ls. Okay, and then I can actually do this, which will give me also the same, which will give me the exit code from the ls command. If the ls is successful, I'm going to get the success command, success value, otherwise non-successful, something like that. Okay, so this is how you can actually retrieve the exit status. Now this last variable I'll skip for now because you're not familiar with the background command. So I have to first explain to you what the background command is, and we come to that when we actually look at the process management. So what is a background process? I'll explain to you that, and that time we'll be able to cover this part. Okay, similar to other programming languages, shell script, you can also use arrays, and there are 2 ways to define the arrays. One is you can use this index-based, definition like this. So you can provide the values using each and every indexes, or you can use this kind of notation where you provide the value as a set or tuples, right? And then there is an array name here. Okay, so there's 2 ways to define the array. How do you access the arrays? Basically, you again use the same notation. However, to read the value from a particular index, you would have to provide the array name in this curly brackets and also the dollar in the front. So again, dollar is reading the value, and then because it is an array, we have to provide this curly braces around that. Okay, so this is how we will be able to read the particular index values. If you want to read all the values, right? If you want to read all the values, then we use index value as a star or an about sign. So about sign or a star will allow you to read all the values at the same time without iteration, right? We don't have to iterate through an array. We can just get all the values at once here. Okay. So again, let's take an example so that it's more clear to you. Okay. So now what we have here is that as I mentioned, there are 2 ways to define the array. So this is one method of defining in the array, and this is the other method of defining an array. What I've done is I've actually used the multi-line comment here. So just to give an example also, so this multi-line comment will basically allow you to comment the complete block. The way it works is we provide a less than sign, 2 times less than sign, followed by a label. Now this label could be anything. It doesn't have to be specific, this label, right? I can also put L, anything like that. And then wherever I put L at the end, it knows that I start multi-line comment from here and I end over here. That's all, right? So basically you provide any label you want here in the starting point, and then once you put that label name at the ending point, that whole block is commented out. So we are commenting this part out, and then we are just keeping this way of definition of the array. And then as you can see, all I am trying to do is displaying the first value, displaying the second value, or the value at index 0, value at index 1, and then we are displaying all the values using the star and the about sign, right? So this is how my array example is going to be used. Let's see if we have any questions. So Google Meet I have used, so I think I'll just check with them. Why it is displaying comma? You can run the example and see it for yourself, right? So I think some of these questions that you're asking, you would be able to figure that out when you run the shell script yourself, right? If you don't understand still, then you can ask the question in the next lecture. Okay, so I will definitely try to answer all the questions as far as possible. However, there are certain things which you have to learn through the experience, right? So that is what I would suggest. Will this support nested comments unlike C or C++? Well, there is a block comment and there is a single line comment. There are only 2 types of comments in shell script. Submission date, I'm not going to talk about it now. If the VirtualBox is not supported, you can try VMware. VMware is another software that can be used. I have not used it, but you can try that. That should work. Can share steps of the shared file thing that you told in the starting of that. Those steps are already available in the PDF file that I've shared with you, where you have to install the VM VirtualBox in the and the Ubuntu. Those steps are already there. I mean, if you follow those steps, you will be able to share the files between the host machine and the guest machine. So please don't ask me questions. The Q&A, please only ask the questions related to the lecture. Okay. If you have questions about the lab stuff, let us take it during the lab time. Right. I'll not be able to answer the questions about the lab stuff right now, because otherwise we'll be wasting too much time on that, and we will not have enough time to cover the things that we want to cover in the lecture. Okay, so basically array.test is what we are, is what we are running here, right? Let me see another thing. You are asking me to run things in the lectures, right? But I have already provided you shell scripting lecture and the code files, right? Why don't you try to run it, and see what happens, right? So this is the reason I am providing you this stuff ahead of time. You have the access to those content. you can try explore it yourself as well, right? If you don't understand something, if you have questions about what we are covering, definitely ask. I'm not against asking questions, but there are certain questions which you will have to explore yourself, right? I'll not be able to give you practical whatever knowledge that you gain through the practice. That knowledge somebody else cannot impart it to you, right? That has to be experienced by yourself, right? That's what I'm saying. Okay, so this is one way of doing it, right? And then I said that you can actually comment out this part, and then you can actually uncomment out this part. So to do that, I will actually comment out the label thing, right? So I'll comment out this line and comment out this line, which means that this whole block is now enabled, right? So we have whole block enabled, and this is the array definition now for us, because I have actually commented out this particular line. So now the array definition is through this, and this is how we are going to run the echo command. Okay. So let me run the array test again using that new definition, and I am expecting to get the same information again, because both the arrays, right, both the definitions are done for the same values. The only difference is that the way the definition is done is different. Now, if you want to really see that whether this is working or not, I can actually change one of these values to, let's say, 5, and this can be changed to 4. Okay, and then now if we run it, then you will see that the values will be different, right? So you can see that second, fourth, and fifth, something like that, right? So whatever changes we did here, those changes are now available. I should have done this 3, but anyway, so those changes are available here, right? So we know that it is using this, this particular array definition and not this one. Okay, so this is how we will be able to use the arrays. Okay, then we have operators, right? Then we have operators. Let me see. Okay, so we have operators, arithmetic operators, and most of them we have plus sign, minus sign, multiplication, division, modulo operator, equal to sign, equal to is used for the condition, not equal to again is used for the condition, right? Now, if you want to create, write an expression where you, let's say, add 2 values and store the result into the third, then this is how you would be able to write it. So you have to add, shell script is very strict about the syntax. Very, very strict about the syntax. So you can't put spaces in the front and back for the equal to sign also. It has to be exactly like this. Okay. So variable name, which is your output variable, equal to sign, and then this is my inverted single quote, right? Inverted single quote, expr space $A. So $A is going to read the value of A variable. Space plus $B is going to read the value of B variable, and then again inverted single quote. This is how I'm going to write my expressions, right? So this is going to add the values of variable A and B and assign that answer to the variable C. Okay. If you want a simple assignment, then you don't have to write this expr thing. You can directly do it like this. If you want to write a condition, you have to write it like this. Again, after angle bracket, there is a space. Okay, then there is $A space equal to sign, then $B space, and then so again, just make sure that the syntax is strictly followed. If you don't follow this syntax of the shell, programming, then it doesn't like it. Okay. Relational operators equal to, not equal to, greater than, less than, greater than, equal to, less than, equal to are written like this. And then logical operators of ending, oring, and not. Right? This not is basically inverting the condition. That's what this not is all about. Right? There are a couple of special operators for the strings to check for the zero length and to check for the non-zero length. That's basically what these two operators do. Okay, so some basic operators will use it through the code, right, in the subsequent examples. There are some file test operators, right? So generally speaking, shell scripting, in the shell scripting, we have to deal with files and directories a lot because that is the first small program that you are going to be writing and running it on the terminal window. You may be calling C program from your shell script, right? Or directly, but shell scripts are always executed generally through the terminal window. So you deal with some file operations here as well. Right, so let's say you want to check whether a given value, given string is a directory or not. You want to check whether a given string is a file or not, right? A path to a file or not. You want to check whether you have a sufficient permission to do reading, writing, and executing. Okay. You want to check whether the file has size greater than 0. Whether you want to check if the file really exists or file do not exist. So such things can be done, right, in the shell script, and these are the options for that. So again, we'll take a look at through the examples. So in this example, all we are trying to do is we are trying to check if the file exists, and I actually changed this line by mistake. So let's say I'm going to check for test.sh, right? So this is the file which we have, and we will see whether that file exists or not. Right, so this file do exist. When I do ls_test.h, I do get the file name, which means the file do exist. So now all I'm trying to do here is that I'm storing the file name in a variable, local variable, and then I'm just accessing that value from the local variable. I'm checking whether that file exists or not. If the file exists, then I echo this one. Otherwise, I echo this one. Right? That is basically what I will be doing. Sorry, I should run file test, not test. Okay, so it says file exists. Why? Because the the test file does exist. Now, if I change the file name from test.sh to test1.sh, right, now obviously that file should not exist, right? And so if I run that same shell script again, it will not be able to find the file, and so it says file does not exist. Because if I do ls test.sh, the file does not exist. But test1.sh does exist, right? So let me rename that file back. Okay. Now, the second shell script for the file, what I've shown is how to read the content of the file. Okay. So again, I'm using a variable where I'm storing the file name, and I'm checking before reading that does the file exist or not. So file do exist. We know that. File read.sh is the same file which actually is what I'm going to also execute. So I'm basically reading the same file that I'm executing, and it's fine. Okay. So I'm checking if the file exists, so file would exist. And then if the condition is true, then I'm actually running this while loop. Now what this while loop is doing, this while loop is basically saying that read something. Now what do I read? So the read command basically reads the data from the keyboard. Okay, so it will keep on reading stuff from the keyboard, and each line, when you press an enter, right, when you press an enter on each line, that each line will go into this p variable. So p is a variable which will be storing each line as it is being read, and it's going to display that. Okay, so that is what my while loop does. But I don't want to read the content from the keyboard. I want to read the content from a file, right? And so what I'm doing is, this is basically called redirection of a standard input. What does that mean? It means that the less than sign, if you recall, so the less than sign for the files are used as standard input. Greater than sign is used as standard output. Meaning that I'm saying that whatever input that you provide will come from here. In the standard output case, I'm saying that whatever output that you want to send will be going to the standard output. So standard output is your screen, is your display, right? And the standard output, standard input is your keyboard. So basically what we are saying by specifying this less than sign here is this is not a condition, right? So don't confuse this symbol with a condition symbol. So there is a condition symbol of less than also, and there is a condition symbol of greater than also. But you can see that I don't have an if statement here. There is no if statement here. So this symbol here indicates that the content that I want to send to this read command in my while loop, instead of coming that values, those sentences, instead of accepting those from the keyboard, my standard input, I'm going to be accepting those values from the file. Okay, so I'm basically converting my input, I'm basically redirecting my input. Instead of coming it from the keyboard, I'm actually going to bring those values from the file. And this is how I am able to read the file in my shell script. So I'm basically saying that read each line at a time, and each line will be stored in my p variable. I'm going to display that line here in the echo command, but those lines are not coming from the keyboard. Those lines are coming from this file. That is what I'm specifying this less than sign for, right? So this is basically known as redirection of standard input. Redirection of standard input. Okay. If it is not clear, I'll show you a very simple example. So when you do man cat, so cat command basically says that concatenate the files and print it on the standard output. What is concatenation means? Concatenation means is that combine all the data, right? Combine all the data from all the files, one after the other. So in case if I provide multiple files, let's say I say test.sh, and then I will say file test.sh. Okay, you will see that I provided two files. So both the files content will be displayed here, right? So this part, if you notice, this part, up to here, this part is coming from test.sh file. And then this part is actually coming from the file underscore test.sh file. So both the files are combined and displayed on the output. Okay. Now, if I don't provide any file name, if I just say cat and enter, you see that it is reading, it is trying to read the data from where? From the keyboard. So by default, the cat command, concatenation command, it is trying to read the data from the keyboard, and whatever I enter will be echoed back. Okay, so by default, cat command receives the data from the keyboard and it echoes it back. But now, instead of cat command reading the data from the keyboard, I want to actually take the data from a file. So I can say cat less than sign and then test.sh. So you see that instead of reading the values from the keyboard, it is reading the file, and it is saying that cat is going to accept the input from the file rather than from the keyboard. So in case of cat command, I can simply skip this less than sign. I can simply skip this less than sign and I can simply type the file name, and that is okay, right? So as far as the cat command is concerned, it can actually work like that also. But I'm just trying to show you an example of this less than sign as a redirection operation for the standard input. Okay, so I can also do cat less than file test.sh and then it will work, right? So like that. So in short, less than sign here is basically meant to take the content of the file and feed into this while loop. That is what it is supposed to do. So now when I run this, when I run this file, it is going to basically display the content of this file with line colon in the front for every line. That is what we are accepting, right? And that is what you are getting. Now, of course, if you change the file name here, you can also read something else. So let me just do test.sh here, just to show you that we can read any file we want. So this is your test.sh file. Okay, that is what we are reading. So this is how you can read the file. See if you have any questions. Okay. All right. The other constructs that we have in the shell scripting is if statement, which we have briefly seen. So you can use if starting point, fi as the ending point. You can also use else in between. You can also use multiple else's using elif, right? So these are the three different ways you can write if statement. In C programming language, we have a switch statement. Switch case is what we call, right? Similarly, you also have the same switch kind of statement here. So you can say switch, which here we call as case, and then word is basically nothing but a variable name or something that you provide here. And then you can check for a pattern, right? So you have a pattern 1, pattern 2, pattern 3, and then star is your default pattern. Okay. So again, this condition is similar to this statement is similar to the switch statement that you have in the C programming language. Again, I'll show you an example of this one in one of these slides. You have loops also in your shell scripting. You have a while loop, right, where you provide the condition here, and till the condition is true, it will continue. You also have the until loop, which again will check for the condition and it will continue. You have a for loop here, right? So in the for loop, basically what we do is this is the set of values that you have, right? And in each iteration, these set of values will be assigned to the variable one by one, right? So iteration 1 will get word 1, iteration 2 will get word 2, and so on, right? There's also this select type of loop, which is basically used for creating a menu. So in the shell script, if you want to really create a very simple text-based menu, not a user interface, not a graphical user interface kind of menu, but a very simple text-based menu. If you want to create it, you can actually use the select loop for that, and I'll show you an example for that. So again, you have several types of loops. I'll show you an example of for loop and select loop, and others are, I think, pretty simple to understand. So you can try it out yourself as well. So in the for loop, this is how we would be doing it, right? So you have these three different values that I have provided: option 1, option 2, option 3, or maybe let me just call this as where 1, where 2, and where 3, right? So 3 values are provided in the for loop, and each of the value is assigned to this where variable, local variable of the loop, and that is what I'm displaying. So each iteration it will display different values, right? Now this is a simple function that I've written. We have not covered function for shell script, but just to show you both the different code, I've created a function here. I'll cover the function in the last slide. Okay. So to run the function, all you have to do is type the function name at the at the place where you want to run the function. So I'm going to run the for test function first, which is basically going to call this function and it's going to run this code. That's all. So let me run that. I think the file is called for select test. Okay, created a problem. There's a problem here actually. Okay, so you have three different values. In each iteration, each value is assigned to the var variable, and it is displaying the three different values. Okay. Now, the other type of loop, as I said, is the select loop, and select loop is basically used for menu-driven program. So, what we have done is, let's say we have three different options that is given, right? And each of the option will be able to do something. So here I'm just putting an echo command, but in each of the option, maybe you can call a different executable files, or maybe you can do different activities for different. So let's say option 1 can read a file, option 2 can write a file, option 3 can maybe copy a file or whatever. Option 2 can rename the file, whatever. So whatever different things you want to do here, right, in your select, you can do that. So what we are doing is that in the select, we are giving three options, and it is not going to save each of these values in each iteration in the var variable. It is not going to do that. It is going to prompt us to select one of these three values. So the prompt will be given to us, and we have to select one of these three values. And depending on which value you select in the var condition here, that will be stored in the var variable. And now you can see that I have this switch statement which I'm using, right? So in the switch statement, I'm going to check what is the value that a user has entered. Is it option 1, option 2, or option 3? And depending on that option, I'll be doing different things. If none of these options are selected, maybe I can just display a message saying it's an incorrect option. Okay, so that is how your select statement or select loop will work. So let me, I think I've enabled the select loop. Yes. Okay. Maybe I need to save the file. Yes, I need to save it. So it was in the old code. Okay, so you see now what is happening, right? So it's displaying me that I have OPT1, OPT2, or OPT3 as three different options. So I have to just enter this number 1, 2, or 3, right? So let me enter number 2. So when I enter number 2, it is basically it's knowing that I've selected this option, and so it is displaying that you have option 2 selected. Now it is displaying twice. The reason being that it's displaying once from here and another one from here. So I'm also displaying what value was stored in the var variable. That's why it's displaying the this twice. Okay. Now it's again prompting me, right? So you can see that the shell program is not complete, right? It continuously is prompting me that what is the option you want to choose. So let's say I want to choose number 1, and now I'm going to know that okay, I've selected option 1. So this is how I am going to use these select loops, right? If you want to exit from the shell script, either you can do Control-C, or maybe you can actually write an option to exit the shell script. Okay, so this is how your loops are being used. Now we are going to loop. There are a couple of examples that I've given for the for loop and the while loop also. I'm not going to execute these, but you can take a look at them. These are the examples that also has the break statement and a continue statement. So examples with the loop as well as with the break and continue statement. These are exactly the same as it is working in the C programming language, right? So break means that you come out of the loop, and continue means that you don't execute anything further in the loop, but you just continue the loop, right? So you go back up and go to the next iteration. That's all, right? So that is the example that I've given over here. So you can take a look at that. Now we have a substitution option or substitution, which is one of the, again, a special type of shell script thing that we can do. These kind of things are probably not available in procedural languages. So one obviously thing is that you use the escape sequences. Escape sequences are available in the in C programs also. Like for example, you can use \n for the new line character. You can use \t for the horizontal tab character and so on, right? So you can enable and disable that using the -e, lowercase e or capital E options. So if you use -e option in the echo command, then your these options will be enabled. If you use capital E option with the echo command, then these options will be disabled. So simple example I can show you. If I say echo -e and then \t tab. Okay, so you can see that the tab is there, right? Tab is there. But if I do capital E, you see instead of putting a tab, it is actually displaying \t, right? So you can actually enable or disable in the echo command using the lowercase e or capital E for these special things. Okay. You can do other substitutions which are there in the examples here, but basic idea behind that is one of the way you can use substitution is you want to capture the output of the command that you are running in a variable. So for example, the date command displays the current date and time. Okay, so date command is displaying the current date and time. Now you want to capture this output and store that in a variable. Okay, how would you do that? So what you do is you use this inverted single quote around date command, and that will give you the string output of the execution of the date command, and that is what you can assign to the date variable. So instead of putting the value into the standard output or the screen, it is going to give you the string output, and the string output can be stored in your variables, and that is what we are displaying here, okay, using this date variable. Now the other thing you can do is, if you want to check whether your variable has a value set or not, right? So for example, it may be possible that in the shell script you may be using a variable, but you don't know if the variable value is actually set or it is not set. Maybe there is some if condition somewhere up there, and value could be set or value could not be set. So if you want to check that, what you can do is, in this example here, we have shown that the value is set for the variable, right? Now I am displaying the value here, right? And this value will be 1. Now when you use :-, so :- basically will say that if the value is not assigned to the var variable, then I am going to display 0 instead of the original value, because the value is not there. If I use :sign, then I am also going to assign the value 0 to the variable and then display the value. So here the value is not assigned to the variable. It is only displayed as a default value. Okay, but here the value is also assigned to the variable and then displayed. And if you don't want to assign or display a default value, then you can actually print some kind of a message. So when you use : you can basically display some kind of a message instead of displaying the value of the variable itself. Okay, so there are 3 different options that you have, one of which you can use to check if the value of variable is assigned or not. If it is not assigned, what you would like to do. Okay, so that is how you can do it. So in this case, the value is assigned. So each of these lines will only display the var equal to 1, right? Because the one value is already assigned. But this particular block is repeated here, right? This particular block is repeated here, and here you can see that I have not assigned any value. So basically that one value was assigned here, and I have removed that. I have removed that value assignment. So now no value is set to variable. So now if you look at these, right, you will basically get the default value or this message. That is what I'm expecting from this shell script. Okay. So again, let me run it. Okay, so again, that example of that echo thing is here, and then the date is being displayed here. And now you see this part, right? So you see that this part is coming from the top section, which is this section here, right? This section here, okay? And and you can see that this part is coming from the bottom section here, right? And in the bottom section, you can see that the value was not set, and therefore the default value is being displayed for the variable, and that default value is being displayed from this echo command. Okay, and then in this echo command, it is still not having the variable value set, so therefore it is saying that data not available. But in case if I would have actually used, in case if I would have actually done this here, then the value of 0 would have already been assigned to the variable, and then this message would not have come. That's why I actually skipped to do this here. Okay, but I can do this here down below. I can do this down below. Right. So this is how you can use the substitution. So actually, I've been using this kind of substitution. I've seen this kind of substitution a lot in the shell script. This kind of substitution you may not see depending on the requirement of the shell script. Okay. Now I'm going to cover next slide, which is the redirection part. Now in the redirection part, I have already covered the input redirection, right? So I've shown you that we can use the cat command, and normally the cat command accepts the input from the keyboard, but instead of taking the input from the keyboard, we can redirect the input, and we can actually take the actual input from the file. Okay, so this part I've already shown, right? So basically, the standard input redirection is already shown. I'm going to cover the standard output redirection and standard error redirection. So for the standard output redirection, you have to use greater than sign. Okay, so greater than sign is basically saying that instead of displaying the content on the screen on the standard output device, you put that content into the file. That is what we are saying. And instead of looking at this theoretical aspect, let's just see how this works in practice so that it's more clear to you. So let me say that I'm going to display a content of a file. Let's say foo.txt is a file that is available. ls foo.txt. So you see that this file is there, right? And if I do cat foo.txt, it is going to display the content of that file on the screen, right? Because that is what the cat command does. It takes the input from the file and it displays the content of the file onto the screen. But instead of displaying the content for the file onto the screen, which is my standard output device, I want the content of the file go to another file. Okay, go to another file. So what I can do is cat foo.txt greater than sign, and then let's say I'm going to call another file called output.txt. Now you will see that the content of this file, instead of being displayed on the screen, that content is going into this file. So which means that I'm redirecting. I'm saying that instead of sending the data to the standard output device, which is my screen, send that data to the output file. Okay, that is what I'm doing. So I'm not seeing anything. I'm not seeing anything here. I'm not seeing anything here. Why I'm not seeing anything here? Because the content of the file, instead of getting displayed on the screen, it is going to the another file. Okay, how do I know that? Again, I can do cat output.txt, and this output, this, the content of this file and the content of this file must be exactly the same, right? And you can see that they are exactly the same, because by redirection, I basically said that put the content of the file instead of on the screen, put it in this file, right? That is what I did, and that is why I'm able to do that. Can you please go a bit slower? So what is it that you don't understand, Kavish? Can you tell me? If you don't understand something, you can ask me. So fi is the end of the if statement. It's like you start with if and you end with fi. That's all. Okay. So that is the answer to Anshu's question. Harsh is asking output.txt was already created or it created a new file. Well, look at ls minus ltr and you will know the date and time, right? You will know the date and time. So you will see that this time is the most current one. Let me run that command again to show you that the file is created again. Right, so I run it again, and now I do ls minus ltr. Now you see that the earlier it was 13.09, now it is 13.11. So the new file gets created every time. Okay, so again, see these kind of things. That's why I'm saying these kind of things. In order to understand, you will have to run these scripts, right? We'll have to run these scripts to really know what is happening. Right, this course is all about testing things yourself. So I'm explaining to you, and hopefully you get certain understanding, and then I advise you to run each and every examples that I'm running in the lecture on your computer also. Right. So after the lecture is completed, or even before the lecture is completed, I don't mind that, because I've already provided you the code. You already have the code, you have the PPT of the lecture. So you can either try running the examples before the lecture, or you can try it after the lecture or during the lecture, right? This is the way you'll be able to learn it while I'm explaining to you what is happening. Because like I said, practical knowledge, everything about the practical knowledge cannot be imparted. It has to be learned by yourself. Some of the things has to be learned by yourself, right? So you will have to practice these scripts, these examples that I'm showing you. You will have to practice it, and that's why I'm providing you the recorded lecture, so that you can try it out again. After the lecture is completed, in order to fully understand it. Okay. Okay. Well, we are using cat command so that it displays the content of the file. Cat means concatenation of the file and display the content of the file on the screen. That's why you are using cat command, right? Okay, it is becoming difficult to absorb so many new commands so quickly. I understand that, Kavish. I understand that, and that's why I'm saying that, in the first attempt, you may find it difficult to absorb many new commands. That's why I'm recommending that once the lecture is completed, I give you the recorded sessions. You go through the recorded session yourself and run those examples yourself and try and understand those commands. This is the way to learn that subject. Okay? You won't be able to you won't be able to understand each and everything directly in the lecture. That's why I'm saying that in the lecture, I'm going to explain as best as I can, and then you try things yourself after the lecture is completed. If you still don't understand something, you bring those questions in the next lecture or during the lab. That is where I will try to explain it further in case if something is not clear to you. The content will remain in the foo.txt also in the example. Yes, it will. So we are not deleting the foo.txt file. We are not we are not doing anything with the foo.txt. Okay, so so you can see that ls minus -ltr foo.txt it's still there, right? It is still there. You can do cat foo.txt, right? That file is still there with the same content, and cat output.txt is still there. So in short, what we did is that instead of data going into the output device, the screen, we took that data and put that in another file. That is what we did. In short, we copied the content of the file from foo.txt to output.txt. That is what we did. Okay, that is how we do the redirection of the standard output. Now, if the file output.txt is not there, it will still create a new file. So let me remove. RM is removal of the file. So removing the output.txt so that for output.txt will not exist. Right? You can see that output.txt is not there. Now if I do cat foo.txt greater than sign output.txt, it is going to create a new file, output.txt. You see, file is again created, and that will have the content of the same as foo.txt. Okay, so this is what we are doing. And every time when I run this command, it is creating a new file. Every time it is creating a new file. So the content is not appended. It is creating a new file every time. Okay. If you want to keep the original content, and if you want to add a content to an existing file, okay, or if the file does not exist, you want to create it, but if the file exists, you want to add the content. If you want to do that, then you would use double greater than sign. So the double greater than sign basically is going to check whether the output.txt file exists or not. If it doesn't exist, it will create. You will .sh, and then this is from the file read.sh. Right, so you can keep on adding a content to an existing file if you want by using greater than sign. That is what this second symbol is. Okay, I think we are over the limit, so I'll stop it here. I have maybe a couple of slides left, but it's okay. because I think it will still take maybe another 10 minutes or so, which I don't want to take over. So if you have posted any questions, let me take them. How does Control plus C command works? If you have used the computer before, you would know, press a Control key. Along with that, you also press the C key. Okay, press the Control key and press the C key together. That's how the Control C command works. Mount files, you're not able to mount files. Well, see, if mounting is the problem, you can still write your files into the guest operating system. But like I said, the problem could be that if you lose your virtual machine, you may lose your source files also, right? That is the reason I mentioned that you should you can see if you can try to mount the files. And the problem actually is that if I mean, in order to solve certain issues like mounting files and stuff like that, I have to actually look at your laptop. I mean, it's difficult to do it virtually, right? So one suggestion I could have is you can try to take help from your friends, those who have been able to successfully do it, or you can try reaching out the help desk also. They have tools to actually connect to your machine, and maybe help you with that, right? So you can maybe try to do that as well. Or if you send me the script or something, I will try to take a look at the script if the script works fine. But see, point is, if you have followed all these steps properly, generally speaking, I don't I don't feel that you would have had a problem. So one of the important thing that you should do if you're not able to mount files or something like that is to make sure that you have followed all these steps properly, right? And go through that one more time. Couple of rounds you should do to make sure that you followed all these steps. If you are getting an error, I also had an error, sometimes. Try to search them on the internet. I mean, you guys have internet at your disposal. Most of the error solutions will be available on the internet, right? So also try internet. So I'm not saying that we don't want to help you, but it's sometimes difficult to help remotely, right? Without looking at a computer, it's sometimes difficult to help because I don't know how you have done the setup, which options you have selected, how, and all that. So that becomes difficult for me to, that basically creates a problem for me to, help you with. Okay, so that's what I would suggest. So try, take help from your friends or take the help from the internet help desk, and then possibly send me the script also. I don't definitely mind looking at that. But I don't know how to remotely connect to your machine and then help you, right? Help desk has those tools, so hopefully they should be able to help you a little bit. But I think internet is your best bet. I can honestly say that if you try search errors on the internet, you will definitely find solutions to work with it, because this is not a new technology. I mean, a lot of people has been using this technology for a while now, right? Is the shared file procedure valid for any guest OS? Well, not always necessary. I mean, so your guest OS has to be compatible with, with your virtual box, right? So if you use guest OS on a virtual box, generally speaking, the procedure that we are following, especially the Linux-based guest OS, will be able to do it. But I don't know if it is. I mean, it's a very vague question you are asking me, right? you know how many different operating systems there are in the world. It always, everything cannot work on all the OS the same way. Every operating system has its own different things, right? So I'm saying that it will work for majority of the Linux systems, Linux based system, Unix based system, but again, you will have to validate that for each of the guest system. Okay. My laptop has 4 GB RAM and VirtualBox is not working on my device. It starts. Well, again, I would say, Harsh, try to take help from the help desk. See if you can take their help. Because 4 GB RAM, I think, is sufficient. My previous laptop, I also had 4 GB RAM with 2-core processor, and I did not have a problem with that machine. So try to take help from help desk in case if you are stuck with that. Are we allowed to concatenate new files data in new line, or it gets added to the cursor? So it gets added to the cursor position, right? So the concatenation is basically just taking the same exact content of the file and combining it together. In the installation of Ubuntu process, it asks for the amount of RAM. So what want to know whether no. So basically, RAM is shared between your host operating system and the guest operating system. So the RAM that you are allocating to the guest operating system, basically what you are saying is that how much amount of maximum RAM you are allocating to the guest operating system. So the host operating system will definitely use some amount of RAM, and then the RAM that you have allocated for the guest operating system, maximum of that much amount it will be allowed to use. Okay, so that is how this thing works. Basically, it is sharing the same RAM, right? It's sharing the same RAM. So if the host OS is, for example, if you have 4 GB RAM, right, you are allocating 1 GB to the guest, and obviously 4 GB is available to the host. So if the host is using 2 GB, then the guest operating system will be allowed to go up to 1 GB. But if the host operating system requires more space, more RAM, and it doesn't leave enough RAM for the guest, then obviously guest will be able to use only that much RAM which is available. Many times the guest operating system will use something called as virtual memory. Virtual memory is created in the disk drives. So in that case, even your virtual machine will work, but it will be slightly slower because the data of the RAM is actually coming from the disk rather than from a normal memory. Okay. We need to submit the lab work immediately after the lab sessions. Yes, you do need to submit the lab work immediately after the lab session. We'll talk about this in the you can check with your TAs in the lab. For the generally, I'm expecting everyone to submit the lab immediately after the lab session. Okay, if there is a genuine reason in a particular lab, right? I'm not talking about all the labs. If there is a genuine reason for one particular lab, you can request TAs and they can talk to me, and we can extend the session time. But it is not that every time we will extend it, right? So it has to be a very genuine reason, right? Why you want to extend it. Okay, so we'll see depending on lab by lab. But generally speaking, I'm expecting you to submit the lab assignment immediately after the lab. Any other question from anyone? All right. So thanks everyone.